demand has increased due to the rising electricity usage. We use electricity every day for lighting our home and powering device. As the energy demand increases, the reliance on non-renewable sources like fossil also rises. It will lead to the fossil depletion in the future. To address the issue, solar PV has been introduced as the long-term alternative. Segment 1. Increasing load demand puts the stress on the power grid, causing the lower voltage value. It is because the system operates closer to its stability limits. The major problem could occur during this time was disruption and blackout in the distribution area. Therefore, it is necessary to identify the weakest bus. The weakest bus is meaning that the bus is giving the lower voltage value even though the load demand has not increased. Limitations exist in addressing the power grid challenge in meeting growing electricity demands. So, for example, this includes the needs for system upgrade, such as a new transmission line and substation, which can be costly and time-consuming to implement. Therefore, installing adaptive solar PV at the weakest bus in the existing power grid to enhance the voltage stability. So, why this study used the solar PV? It is because solar PV is the one of the fastest renewable energy in Malaysia. Objective 1. To perform voltage stability analysis on 57 bus test system before and after connecting to solar PV. VCPI is a technique to measure voltage stability rather than observing the voltage magnitude. Objective 2. To optimize the solar PV placement. This study will identify the specific buses for integration, not applying solar PV throughout the entire of the system. Objective 3. To evaluate the effectiveness of the different solar PV configuration and placement in maintaining the voltage stability. The scope of the research. Number 1, the 57 bus system is simulated using MATLAB. Then voltage stability will be analyzed. VCPI is used for assessing voltage stability. And lastly, the weakest bus are evaluated. For the literature review, this study requires a comprehensive analysis of these 4 subsections. Next, I will explain the flow of the research. So first, perform the power flow analysis on 57 bus test system using Newton-Raphson method in MATLAB. The result display the voltage magnitude for all buses. Perform the voltage stability using VCPI. Calculate the VCPI using the formula and analyze the finding to identify the weakest bus. So if the weakest bus is not identified, recompute the VCPI until it is found. This will be the preliminary results. Then connect the weakest bus to solar PV and perform the load increment in MATLAB. Analyze the result using the Excel graph, and lastly, proceed with the thesis writing. This is one line diagram of the 57 bus system consisting of 1 slack bus, 7 generator buses, and 42 load buses. Next, use all these formulas to calculate the VCPI manually. The power flow analysis techniques include Gauss-Seidel, Newton-Raphson, and quasi-Newton methods. The Newton-Raphson is used in this research because it provides accurate results. Next, for the MATLAB code, the code is adjusted to match the standard IEEE 50 bus test system as shown in this slide. The graph shows that the lowest voltage magnitude at bus 31 while the highest at bus 1. In a power system, voltage magnitude at each bus must keep within the permissible limit of 0.95 to 1.05 per unit. There are 5 bus, 25, 30, 31, 32 and 33 show the voltage magnitude are outside from the permissible limits. This occurs because these buses are farther from the major generation switch and have higher impedance. So as impedance increase due to the farther from the generation switch, it will cause the voltage drop resulting in a lower voltage magnitude. So instead of observing the voltage magnitude, the VCPI will be calculated for all buses. This analysis aims to identify the weakest bus in the system. The highest VCPI at bus 18 while the lowest VCPI at bus 23. So interpreting the result, a VCPI close to 0 is considered as a stable condition, while a VCPI close to 1 is indicate that the system is critical to collapse. Based on the graph, so bus 18 is at line 4 to 18 is identified as the weakest bus due to the higher VCPI value. So this bus need to be analyzed. So as previous discussion, so initially they have 5 bus that outside the permissible limit, but after conducting the VCPI analysis, bus 18 is experience the voltage instability. So therefore, rather than also depending on the voltage magnitudes, it is recommended to perform the voltage stability technique for a more comprehensive analysis. In a conclusion, it is proven that first objective, which is related to performing voltage stability using VCPI analysis before connecting to solar PV, has been partially achieved. Then, the simulation's results show that the weakest load bus are identified based on the highest VCPI values. And lastly, the proper placement and sizing of solar PV can improve system stability and support the higher load level.